Okay, so we can start. Welcome everybody, and thanks for coming to this session on FHIRCast. Hopefully you know something about it, but you don't have to. We're gonna go through everything here that you'll need to know and that you'll need to get excited about it. A little bit about myself. My name is Leo Bergnehr. I work at a small PACS company in Sweden called Sectra. And I've been doing so for a good decade probably. Been working a lot with integrations, all kinds of DICOM HL7, FHIR a little bit now, and also a lot with desktop synchronization, which is a hot topic for today. So, context synchronization or desktop synchronization is what we're gonna talk about today. And please, if you want to interrupt with questions, that's all right at any time. I'll try to make this as interactive as possible. So what is context synchronization? In the kind of traditional and simple and also probably the most common case today, context synchronization or desktop synchronization is where you have a workstation at a hospital and you have multiple applications. For example, maybe you have an EHR showing a list of patients, a work list. Maybe you have a dictation system that you need to for creating reports. So these applications, it's crucial that they show the same information, all right? You can't have the EHR showing one patient and the dictation system showing another patient and the PACS system showing images from a third patient. The reports will be kind of random at the best. So it's crucial, and our users will be very sad if this doesn't work. It's a really scary situation when it doesn't work, and it's super important that it does work. So today this is solved by multiple kind of implementations depending on which vendor and which site. There are multiple ways of doing this. Many of the EHRs have their own proprietary ways of doing desktop synchronization. Many PACS vendors, like where I work, we have our own proprietary way of doing this. So which one do you choose? Well, you need to choose one, and the other vendors need to implement that proprietary way of doing it at for every new vendor, and possibly even worse for every site. So it's kind of a mess today, but that's what we have. A little bit more complex situation might look like this. So these are not two displays, these are two computers. This is not very common today, but it isn't very far-fetched if you think about it, that you have custom workstations doing custom work, and you have applications on them, and you need them to synchronize. If you look at this situation, it's even more obvious that this will be the future. You have workstations, and you have tablets, and you have mobile devices, and you want them all to work in some kind of the same context. For example, take an MDT where the doctors go through interesting cases with each other. You have one kind of running the MDT meeting and maybe 10 others sitting discussing it with each other. Wouldn't it be nice if the one running the meeting is running it, everybody else is sitting with their tablet, and they can zoom and measure and do all the stuff they want to do on the images, for example, and all on the same context without having to like manually search and type for the same patient all the time. So there are a lot of situations where this will be awesome. So enter FHIRCast. This is kind of an ongoing adventure. It's been ongoing for a couple of years. We started out with a couple of EHR vendors, with Epic and Sectra, and Cerner has been involved, and recently a lot of more people have caught up the interest and helped developing this. So it's a specification that we're trying to get into maybe one of the next versions of FHIR. Unfortunately, I don't have a logotype here, but if any one of you are interested in designing stuff, that would be great. We have an issue there that you can go into. There's actually, just recently, one sample logotype in there. So if you don't hurry, that might be the one that we choose. So what is FHIRCast? It's it's a specification based on open standards. One of the main pieces in it is something called Websub. Has anybody heard of Websub in here? It was formerly known as PubSub Hubbub, which is a name that I like much more. Unfortunately, they had to go like professional on it. So, but PubSub Hubbub or Websub is crucial to FHIRCast, and it's the whole mechanism of how you subscribe to events and all that. We'll get into that as well. It's a decentralized specification. It doesn't force you into having a central context manager, which is often the case with existing solutions. For example, the one that I work for, we have our own kind of proprietary context manager, and if you want to sync our way, you need to connect to that, everybody. So it's kind of FHIRCast is more relaxed in that matter. You can build this kind of infrastructure and design if you like to, but you don't have to. And of course, it's built on good stuff that we all love. First of all, the data model for sending information back and forth, for saying that the context is now this, it needs to be specified, and of course it's specified using FHIR data models. So that kind of takes some really heavy burden out of this specification, just leaning on all the work that we have in FHIR and all the rich data models we have there. It's also building on, because authentication and authorization is crucial when you kind of want to, if you went to the Smart on FHIR talk, that was greatly describing that. You need to kind of, in order for these systems to start communicating with each other, first you need to know what you're kind of looking at, what context you want to share. And also, you want to be able to be able to do this in a secure manner, so that not everybody, especially when you see this from a perspective where you're not on the same computer anymore, you want to be able to securely say that I want to change this context, and I know that it's okay because I've already kind of set up the trust between the parties. So for that, we're using Smart on FHIR, of course. And FHIRCast is extending Smart on FHIR, so there are additional scopes actually one additional scope for saying that you can synchronize contexts between applications. And in Smart on FHIR launch, you can also bring with you a lot of the kind of starting parameters that you need for FHIRCast. We'll get onto those later on as well, but some important things are the some URIs that you need for calling, like notifying. The parties need to notify each other when stuff happens. So bringing those with you in your Smart launch will kind of remove all the hassle of distributing or discovering each other in some other way. It's also possible to do it in some other way, but Smart is probably, if you have that opportunity and ability, Smart on FHIR is probably the smoothest way to do this. So let's go into some nitty-gritty details on how this specification actually works. So this is kind of the broader schema of how the subscription PubSub workflow works. We have a hub in the center, and the hub is probably, in most cases, some kind of application server. For example, for an EHR, you can see the hub as the system that is probably driving the context. Doesn't necessarily have to be that, but that's probably the simplest way of seeing it and also implementing it. So think of this as perhaps an EHR. In this example, we have it as an EHR, and we have two clients. I mean, there could be more clients or one client, but the clients are a little thinner. Think of them as a little bit lighter. They could also be an application server. So in this case, maybe it's an application server for a PACS and an application server for some cardiology system. So they're communicating with each other server-wise. However, there is also an addition to the specification that we haven't entered in the specification itself just yet, but we're thinking really hard on how to solve this, and that is to allow for even thinner clients. So clients that doesn't even have an application server. You're maybe a mobile app or a web application that runs serverless, or you get the idea. So they should also be able to use FHIRCast. And what we're thinking there is to have a WebSocket connection between these and pass the notification via that instead of server-wise. So please come afterwards and talk more about this, because it's kind of one of the pieces that are most in motion at the moment. So let's go into this workflow in more detail. We have the hub, as I said, and this is it's the hub, and the hub itself doesn't really do much. You need some other party as well. So in this case we have a client A. So the first thing that needs to be done in this workflow is that the client needs to subscribe to the hub. So what is a subscription? Well, a subscription is basically saying, I am interested in this context. I'm interested in this topic, is what we use the terminology here. And I'm also interested in these events. So you might be, maybe a topic can translate to many different things, but a simple way of seeing it is probably like, for example, a workstation. So maybe a topic is equivalent to a workstation. That's the more common case that you have today. But as I mentioned earlier, perhaps in an MDT meeting, it might be something broader than that. So how you discover the topics, that is not really in the specification itself, but it can be like, you can get help on the way using, for example, Smart on Fire. But if you have a common topic, then you're good to go. So this client is saying, I want to subscribe to this topic and these events. So let's go through this message that it's sending. So it's basically sending an HTTP post message to the hub, so it knows about the hub, the hub basic URI that can also be transferred in the smart launch parameters. So what do we have here? Well, first of all, we have something called a callback, and it's simply a callback. So the client says, here, Mr. Hub, when you have something for me, this is where you can reach me. So the little dotted arrow there is basically somewhere in the future when the hub is telling the client A that something happened. So the value there for the whole hub callback is a URI. And the URI is unique for every subscription, so it shouldn't be guessable. You shouldn't be able to kind of know where the hub is sending stuff as callbacks. Then you have a little thing called mode, and that's just a way of saying I am subscribing, or it can also be I am unsubscribing. So you can stop listening for events if you like to as well. Then we have the topic, which is kind of central. And this is both a way of saying that I'm interested in this particular context. Maybe it's a workstation, maybe it's an MDT meeting or something else. But it's also a URI used for the client to say something happened at my side. So now we have two-way synchronization. The hub can post on the callback saying something happened, and the client can post on the topic URI saying something happened. All right? So this is also a URI if you can translate all these encoded characters into colons and slashes. We also have a secret, and the secret is used for something that will come in a little bit into later, in order for the communication from the hub back to the client to be secure, for the client to even more securely than just having a unique callback URL know that this is the actual hub, the actual subscription that I created, that comes back to me now. So the secret here is a key that's used later on in hashing the stuff so that the client can know that that stuff hasn't been tampered with and that it's from the original source that it's subscribed to. And then we have the events. So these are the events that this client is interested in. And FHIRCast, we're trying to kind of create an event catalog so that the events will be as specified as we can from start. So here we have a couple of these events. In the subscription event here, the subscription post message here, we have 2 events. We have open patient chart and we have close patient chart. So perhaps client A here is some application that is only interested in patient changes. We also have other events in this catalog for study changes, logins, logouts, when clients are kind of getting hibernating, that kind of thing. And there are probably events here that we can come up with that we haven't yet as well. All right, so another thing about a little bit about security is that what if an evil attacker tells the hub to subscribe to and tell a callback URI somewhere else? So maybe I'm an evil hacker and I tell the hub, hey, I'm interested in these events, post them over there when you have them. Maybe for some kind of overflow attack, I don't know. But in order to make it possible for the clients to verify that that doesn't happen, basically, this is in place. And this is something, when the hub got the subscription and everything's fine with that, it will also validate that it came from this client. So it's going to send a randomized string back to the callback URI, and the client probably, when it sent away the subscription, is holding on to something like a pending subscription list or whatever. So when it gets this validation callback back, it can see that, okay, I get this validation and I have this subscription that I actually posted, so this is fine. So the client is just returning, yeah, it's fine. So, and then the hub actually have this subscription validated and active. So now we have a client that has subscribed to events and a particular topic for this hub. And maybe we have another client as well that has done the exact same thing, client B. So now we have 2 subscriptions on the hub and the hub itself. So as I mentioned at the start of this, the details here, maybe this is an EHR, a PACS, and a cardiology system, for example. So what happens if somebody changes the context in client A? Maybe they have their mobile app and they're pressing another patient in the work list. Well, client A then sends this post message back to the topic URI. So the topic is what you see there next to the post. And with it, it's sending a JSON blob. So let's look what that looks like. So this is basically the information that contains everything that the parties involved in this context sync should know about that happened. So what do we have here? Well, first a timestamp. That's not really interesting. We have an ID, and that's mostly used for if we have. It should be unique for every notification. So it's more used like if you have fail notifications to be able to see if it's the same one coming again. So not super interesting. This is more interesting. This is the event, a little event object here, and here we have the good old topic as well, and the event. So this is the event that actually happened. Somebody opened a patient chart here, and even more interesting is the context. Here we have the FHIR model. So this is where the FHIR happens, if you will. We have a key specifying which, and this is specified in the FHIRCast specification. The key here is patient. There are other keys, for example, study. So this is saying here is a patient, and in this flame here, there is it will expand to a FHIR resource, basically, the patient resource. And if you have a study, it will expand. There is a study resource, and you can have both, but they're probably not required in all the types of events. So the event catalog specifies these are the events, And for event A, you have something that is required in terms of resources. Some events doesn't even have any context resources at all. For example, logout wouldn't have any resources attached to it.
Can I ask a question?
Sure, yeah.
Why have you chosen to send the whole resource rather than just like identifiers or ID?
Yeah, excellent question. So what we're doing here, we're actually we're not sending the whole resource. We're relying on something called _elements. So you can specify what parts of the resource you're interested in. So if the one sending the resource supports that, then you can just have parts of it, basically.
But are you required? I mean, so
It is not required.
determining what to send, or is it configuration, or
I'm sorry?
does the sender determine what's being sent, or do we need to
Yeah, well, yeah, exactly. So there are required parameters that you need to send, but if I understood your question correctly, maybe you think it's unnecessary to send everything.
Yeah, I mean, that would be maybe redundant. I mean, if everybody's sharing the same file server,
Yeah.
kind of store their data.
Right. So exactly. So with the _elements, we're trying to kind of reduce the amount of information that's being sent, but you don't have to implement it. So in that case, you would send more information than what's needed. But yeah, what you get then is maybe perhaps a little bit less performance, and yeah. So we're trying to address that with the _elements. Right. Now we can watch this flame for a couple of minutes. It's cozy. Okay, so if you remember, I mentioned something about this secret. So now that the hub has actually got the notification from the client, and if there are other clients subscribed to the same topic, to the event that has actually being passed from client A, now the hub needs to broadcast that to everybody else, right? And in order for the security for client B to know that this is sent from the hub that it actually subscribed to, the hub is sending this HTTP header X hub signature with this, in this case it's a SHA-256 hash, and this is something called an HMAC, if you know what that is. So it's basically just taking the payload of the request together with this secret key that the client sent at subscription stage, and hashing these together and sending that hash. So client B can now verify that, okay, I know the secret that I sent, and here is the payload, here is the hash, so I'm gonna hash this as well and see if I get the same hash, basically. And you can use different kind of hashing mechanisms. That's why there's a SHA-256 equals, and then the hash, so maybe you can have SHA-512 equals or something else. And maybe we have a more exotic scenario here with more clients. Then the hub will broadcast this to everybody who's interested in this topic and this event. So it's the same mechanisms for everybody here, basically. And the simple scenario, maybe this is more common in reality, is you have the HR here, which is the hub, and maybe you have a dictation system, and they're communicating back and forth. The hub is notifying the client is notifying the hub back. So right, so in order for FHIRCast and the specification to be successful, we believe it's crucial to get developers up to speed quickly. And that's why we have created, well, first we created one sandbox, which is a .NET Core application, and then our good friend here, Martin also created the sandbox in JavaScript. So we now have 2 sandboxes. And these are open source, and they are under the GitHub organization that we have for FHIRCast. And it's something that if you're interested in this, I really encourage you to go into Hiren and maybe help out with them, because it's quicker to write something in specification, change that, compared to actually changing the code. So they're lagging a little bit behind. Although we believe that specification is actually kind of stabilizing now, so hopefully they'll kind of get to the specification fairly soon. So please check them out if you like. And I'm actually gonna try and show you some of this as well to get a little bit more concrete in how this how this could work. So here is what you can do in order to get these the .NET sandbox up and running. So it's fairly simple. You clone the repository and you use .NET in this case for just running a hub, and a Websub client is what it's called here. And we have separated these in order for it to be clear that the hub is according to the specification. The Websub client is also according to the specification in some regard, at least how it's communicating with the hub, subscriptions and notifications. However, if you look at this as an application server, there will always be some kind of proprietary mechanism to communicate with your web clients, your UI, that the users are actually seeing. So in that case, this is used using SignalR, but that should be seen as some proprietary mechanism for communicating with the user, with the UI. So let's see if we can get this to display. No? There we go. So here I have cloned the repository, and I am going to run this Websub client here, and I'm going to run the hub over here. So these are now 2 .NET Core applications running 1 web server each. And now we have that, we have the hub running, we have the client running. So here is the client, and if you like UX, maybe you want to squint a little bit because there's room for improvement here. And here you can do a lot of stuff. So basically you can subscribe to a hub, and you can post notifications to a hub, and you can specify which metadata do you want to notify, for example. So let's take this one here on the left. Yeah, same left. And I want to subscribe that to a hub here running on port 5000. That's the one that I just started. I want to use a topic here. Let's use this topic. So it's API. This is the same URI and just /t there. And then events, maybe I want to use open patient chart that we just saw. So I'm subscribing to that. And over here on the other client, I want to notify the hub of something. So let's say I want to notify on the same topic, on the same event, for a patient identifier 123. And now if I press update, it appeared over here magically. So what's happening here is if we try to translate this into a real life scenario, is we have this application server application on the right talking proprietary to its application server. The application server is notifying a hub, and in this case, the hub has another subscriber for the same topic and event, which is another application server. That application server gets the notification from the hub, and it sends in a proprietary way up the information to its UI client, which is the client on the left here. Was that clear? Yeah. So basically server-side desktop synchronization. And as I said, we're trying to get some kind of WebSocket mechanism in here to get this to work with thinner clients as well. The idea there is that you have a WebSocket connection so that the server can send something up to the client directly saying, hey, something happened, and then the client can go fetch that information. That's the plan for now. That also makes it easier to get this working behind firewalls, because if you have a scenario where you cannot reach each other, you cannot do the callback because maybe you're running the hub in the cloud, for example, you can't get back in, then it would be easier to have this WebSocket mechanism to be able to just ping the client saying something happened, and they can go fetch what happened. So you should definitely get involved in this if you're excited about it as I am. And there are multiple places of doing this. First, go read the specification. It's on FHIRCast.org. And we're trying to run this everything as much as possible on GitHub. So we have a FHIRCast organization on GitHub. There we have the documentation and all the issues. It's in the docs repository. We have the 2 sandboxes that are kind of trying to describe this as reference implementations. And we also have the Zulip stream FHIRCast, of course. So all of these are great places if you want to have questions or if you have feedback, which is extremely welcome and needed, I think. So thank you very much. I'm Leo Bergnehr, and after this talk we will have a geek out session that Martin has provided, and there's also exercises if you have had a look at those. And we'll see how many people are interested, if we can all fit in one room, or if there are too many, we will be at the HR tables, and maybe I'll run back and forth between them. So thank you very much. Yeah, a question?
One question maybe. Classical context management, you always have a kind of transaction management so that you are assured that every application switches the context. Is there anything similar in FHIRCast?
Yeah, no. So the question is, if we have, in a traditional context manager, you have a transaction mechanism often in place where you're sure that everybody switched the context. What we have seen is that this is often making it too complex for people to adopt it. So we're trying to be more relaxed in that manner. What we do have is that you should respect the return codes that you get. So for example, when the hub says to a client that you should switch the context, and the client returns with something like an error or something that signals that it couldn't do it, then the hub needs to do something about that. So I mean, you can't. Yeah, so this is not strictly in the spec, except for the error cases should be handled, basically. So but we're open to feedback there as well. We're trying to kind of weigh between the implementation burden and also, of course, the security that you need to have in desktop synchronization. The security in terms of showing the same patients. Question?
So for the callback interface from the hub to the client needs to be a web server running, right?
Yeah.
So is it appropriate for mobile clients, for example, if you want to have a web server running on a mobile client?
Yeah, so the question is, for the callback, you need a web server running, so the client needs a web server running. Well, yes, for the first thing that I described, Websub, you need a client, so that would be to the application server in that case. And the other way of solving this is what I mentioned with WebSockets, where you have and then you can have, because WebSockets is you can use it in browsers. All browsers have support for it. There is a good client library support for many other applications as well, so maybe for mobile apps, for example. So in that case, you wouldn't need a web server running. You can just, you get a notification from the server directly from the hub saying that something happened, then you go and fetch that information directly from the hub. So you wouldn't have to go through the application server in that case. And another maybe related scenario, there's nothing in the specification saying that this should be server-side sync. We have scenarios where similar specification or an early version of it has actually been adopted by a customer, and they have a mix of thick client and web-based client, and they're actually hosting a web server on the thick client, and the web-based application is communicating with that locally on the same host. So there's nothing in the specification, although I wouldn't recommend that scenario, there's nothing in the specification that prevents it. Okay, so see you at the exercises or at the Geek Out session or tonight over a beer. Yeah, thank you very much.